Welcome to Narada Academy. In this video, we are going to discuss about how to find the solution of ordinary differential equations by using Laplace transform. Already I have uploaded two videos regarding Laplace transforms and inverse Laplace transform. Okay, so if you want to know the basics of Laplace transform, kindly go through both the videos. I have given the link in the description box. Okay, now here in this video, we are going to see how to solve ordinary differential equation using Laplace transform. So here mainly we are going to make use of these two formulas. One is L of f nth derivative of t equal to s power n L of f of t minus s power n minus 1 f of 0 minus s power n minus 2 f dash of 0 etc. up to minus f n minus 1th derivative of 0. Okay, and L of t power n into f of t equal to minus 1 power n into d power n by ds power n of L of f of t. So these two formulas are primarily used in this video. Okay, now let's go to the problems. Solve the following differential equations by using Laplace transform. The first equation, d square y by dt square plus 2 dy by dt minus 3y equal to sin t. Given that y and dy by dt both are 0 when t equal to 0. Okay, look at this equation. This is a second order ordinary differential equation with constant coefficients. So we are going to find the solution by using Laplace transform. Now this equation can be written as y double dash plus 2y dash minus 3y equal to sin t. So what is the condition given here? That is, these are the initial conditions. Y of 0 equal to 0 and y dash of 0 equal to 0. So these are the initial conditions given in the question. Now you take Laplace transform on both sides of this equation. So what do you get? L of y double dash plus 2 into L of y dash minus 3 into L of y equal to L of sin t. Now L of y double dash. So this is obtained from this formula. Okay, this is for nth derivative, no. For second order derivative, it is s square into L of y of t minus s into y of 0 minus y dash of 0 plus 2 into L of y dash. The same formula for first order derivative. S into L of y of t minus y of 0 minus 3 into L of y of t equal to Laplace of sin t is what? 1 by s square plus 1. Okay, right. Now in the problem they have given y of 0 and y dash of 0 are both 0. So these two terms will become 0 and here also this y of 0 will become 0. So simply what we have, s square into, for my convenience I am taking this L of y of t as y bar. Okay, just for simplification I am writing it here. So s square into y bar, both these terms are 0, no, plus 2 into s into y bar, okay, minus 3 into y bar equal to 1 by s square plus 1. Okay, now take this y bar as a common factor outside. So what we have, s square plus 2s minus 3 into y bar equal to 1 by s square plus 1, or simply y bar equal to 1 by s square plus 1 into, now this term can be factorized as s minus 1 into s plus 3. So this is my y bar. Actually, they have given one differential equation. We want to solve this differential equation. That means we want to find what is the value of y satisfying this differential equation, isn't it? So for finding y, now I know what is y bar. Y bar is nothing but Laplace of y. So if you take inverse transform on both the sides of this equation, simply what you get, y equal to L inverse of, that is inverse Laplace of 1 by s square plus 1 s minus 1 into s plus 3. So we want to find the inverse Laplace transform of this function. Now look at the denominator. Here product of three terms we are having. So we have to separate this by using the method of partial fractions. Then we have to find the inverse Laplace transform. Okay. So how do you take? By using partial fraction. These are linear terms, no? So it will be what? A by s minus 1 plus b by s plus 3. For linear factors, you have to take it simply a by s minus 1 plus b by s plus 3. This is s square plus 1, no? So for terms of this type, you have to take it like cs plus d by s square plus 1. Okay, right? Now you take LCM on the right hand side. So s minus 1 s plus 3 into s square plus 1 in the denominator. So numerator will be a into s plus 3 into s square plus 1 plus b into s minus 1 into s square plus 1 plus cs plus d into s minus 1 into s plus 3. Now look at the left and right hand side. Both are having the same denominator. So we can cancel them. So simply what we have, 1 equal to a into s plus 3 into s square plus 1 plus b into s minus 1 into s square plus 1 plus cs plus d into s minus 1 into s plus 3. My aim is to find the values of the constants a, b, c, d. Okay. Right. Now from this equation, the highest degree of s is cubic 3, no, that is cubic equation on the right side. So now you find the coefficient of s cube on the right side. So s cube means what? No need to expand this fully. Okay, simply you can see s cube is obtained by multiplying this s and s square, no, so a into s into s square, it will be a s cube. So coefficient of s cube for this term is simply a, and here it is what? B, and here it is what? Only c. For d only s square will come, no s cube for d. Okay, so a plus b plus c, this is the coefficient of s cube in the right side, but in the left side there is no s cube term, no, so it is equal to what? 0. And similarly equate the constant term. Okay, just for easily obtaining the values of a, b, c, d, I am equating the highest power term and the constant term. Okay, right. Now constant term. How will you obtain the constant term? Look at the constants here. Plus 3 plus 1. No? When you multiply these two, you will get constant. So 3. 3a, and here minus 1 plus 1. So minus 1. Product. Their product is minus 1b. And here c, for c you will not get any constant term because c is already having with the s, no. So no constant term will appear for c. Only for d you will be having minus 1 into 3 what? Minus 3d. Equal to, on the left hand side the constant is 1. Okay, other coefficients I am not equating because they may get complicated. So simply I am having two equations. Okay, but these are not enough for me to find the values of A, B, C, D. Okay, for that what I am going to do is I am going to substitute some values for S. See, if I put S equal to 1, this B term and this C, D term will get cancelled. That is, they will become 0 because they containing S minus 1, no. So when you put S equal to 1, both these terms will become 0. You will be having only the value for A. So put S equal to 1, you get 1 equal to, so 1 plus 3 is what? 4. 4 into 2, isn't it? 4 2s are 8. So 8a equal to 1, or simply a equal to 1 by 8. Right. And then another one is, see, s plus 3 term is there, no? So put s equal to minus 3. So when you put minus 3, this term and this term will become 0. You will be having only the value for b alone. So 1 equal to, so minus 3 means what? Minus 4. Here it will be 10. So minus 40 b equal to 1, or simply b equal to minus 1 by 40. Now I know the values of a and b. Substitute the values of a and b in both the equations so that you can obtain the values for c and d. Okay, so after obtaining the values of a, b, c, d, you substitute it in equation number 1. Okay, so what you get? Y equal to L inverse of a by s minus 1, no? So 1 by 8 by s minus 1, b by s minus 3. So minus 1 by 40 by s plus 3 plus cs plus d, no? So minus 1 by 10 s minus 1 by 5 by s square plus 1. Now find the inverse Laplace of all these functions. That will give you the solution y. Now 1 by 8 is constant. I can keep it outside. Laplace, inverse Laplace of 1 by s minus 1. S minus 1, na, it is what? E power t. And then minus 1 by 40 into inverse Laplace of 1 by s plus 3. So it is e power minus 3t. Then here two terms are there. So consider them separately. The first term is minus 1 by 10 into s by s square plus 1. It is cos 1t. Okay. Another one is minus 1 by 5 into 1 by s square plus 1. It is what? Sin t. So this is the solution for the given differential equation. Okay. Right. Then next problem. D cube y by dt cube plus dy by dt equal to e power minus 2t, given that y of 0, y dash of 0, y double dash of 0 all are equal to 0. Okay, this equation can be written as y triple dash plus y dash equal to e power minus 2t. Right. Now you take Laplace transform on both sides. So L of y triple dash plus L of y dash equal to L of e power minus 2t. Write the formula for the third derivative. S cube into L of y of t minus s square into y of 0 minus s into y dash of 0 minus y double dash of 0. Okay. Plus here the formula for the first order derivative. S into L of y of t minus y of 0 equal to Laplace of e power minus 2t is simply 1 by s plus 2. Okay. Now all these values are 0. It is given in the question itself. So y of 0, y dash of 0, y double dash of 0. They are all 0. So simply what I get? S cube plus all these are 0, no? S cube into y bar. This L of y of t I have taken as y bar plus s into y bar equal to 1 by s plus 2. So now you take s outside. So s into s square plus 1 into y bar equal to 1 by s plus 2, or simply y bar equal to 1 by s into s plus 2 into s square plus 1. So we have to find the inverse Laplace transform for this function. That will give you the solution for the differential equation. So for that, again I have to split the right hand side by using the method of partial fractions. So the denominator is similar to the previous problem. two linear factors that can be taken as a by s plus b by s plus 2. This is quadratic term which you have to take it as what? Cs plus d by s square plus 1. Okay, as before the previous problem, I am equating the coefficient. Highest coefficient of s is here s cube. So I am equating the coefficient of s cube and what? Constant term. So here the s cube term is what? A plus b plus c equal to this side s cube term is 0, no? So a plus b plus c equal to 0. And constant term 2a. Okay, b for b no constant term will be there because b s is there, no, so no constant term. And c for c also no constant term, and d also no constant term. Only a is having constant term 2a. 2a equal to constant term on the left hand side is 1. 2a equal to 1 implies what? A equal to 1 by 2. Now you give some specific values of s. S is equal to minus 2. If you put this term will get 0. Only this term you will be getting. This will also become 0. So minus 10b equal to 1 or b equal to minus 1 by 10. So after finding b, I know the value of a already know. So substitute it here, you will get the value of c. Okay, then for finding the value of d, you arbitrarily give any value for s. Okay, I am giving s is equal to 1. So by giving s is equal to 1, I am getting 1 equal to 6a plus 2b plus 3c plus 3d. Substitute the values of a, b, c and you get the value for d. Okay, right. Now y is given by inverse Laplace of 1 by 2 by s minus 1 by 10 by s plus 2 plus minus 2 by 5s into s by s square plus 1 minus 1 by 5 by s square plus 1. So what is the inverse Laplace transform of 1 by s? 1 minus 1 by 10 into this is 1 by s plus 2, no, it is inverse Laplace transform of e power minus 2t. And then two terms are here. The first term s by s square plus 1 is cos t. Another one is 1 by s square plus 1 is what? Sin t. So this is the solution for the given differential equation. Right? So in the previous two problems we have solved two separate differential equations. Now the third problem I have simultaneous linear differential equations. That is two equations taken together. See, look at this equation. Dy by dt plus ay equal to x and dx by dt plus ax equal to y. Right? So here x is a function of t and y is also a function of t. These are called simultaneous differential equations. Okay, and they are of first order equation. So these two equations together we have to take and we have to find the solution for x and y. Both the variables we have to find. Here x and y are dependent variable which depends on t. Okay, right. Now the procedure is the same as before the previous problem. Okay, no change in the procedure, but the given equation is somehow different from the previous equation. Now take the given two equations. So this is y dash of t plus ay minus x equal to 0. This is x dash of t plus ax minus y equal to 0. With x of 0 equal to 0 and y of 0 is given to be 1. Okay, now you take Laplace transform for both the equation. So L of y dash of t plus a L of y minus L of x equal to 0 and L of x dash of t plus a L of x minus L of y equal to 0. Now for this one apply the formula s into L of y of t minus y of 0 plus a into L of y I am usually taking it as y bar minus L of x I am taking as x bar equal to 0. And similarly here s into L of x of t minus x of 0 should be there. Okay, plus a into x bar minus y bar equal to 0. Now you put x of 0 equal to 0 and y of 0 equal to 1. So s into y bar plus a into y bar, this minus 1 I put here, plus a y bar minus x bar minus 1 equal to 0, and here s x bar, x of 0 is 0, no, so it won't come, plus a x bar minus y bar equal to 0. Okay, let me rewrite this equation. So s plus a into y bar minus x bar equal to 1. Another equation is what? S plus a into x bar minus y bar equal to 0. Okay, now what is my aim? To find the values of both x and y. I am having two equations, no? First you take the two equation, okay, remove any one of them. Either you remove x or y, x bar or y bar, find the value for the other variable, and then again you take the pair and you have to remove the other variable and you have to find the value. Okay, the first step what I am going to do is I am going to remove x bar. So if I want to remove x bar, here it is coefficient is minus 1, here it is s plus a, no? So multiply the first equation by s plus a. So what do you get? S plus a the whole square into y bar minus s plus a into x bar equal to s plus a. Take the second equation as it is. So s plus a into x bar minus y bar equal to 0. Just you add the equation because they are of opposite signs, no? So they will get cancelled. So what you get? S plus a the whole square y bar minus, here it is minus, okay, minus y bar equal to simply s plus a. Okay, right. So If you take y bar outside, you will be getting y bar into s plus a the whole square minus 1 equal to s plus a. So y bar equal to s plus a by s plus a the whole square. Here it is minus 1, right? So y equal to L inverse of, that is inverse Laplace of this function. Look at this function. Here wherever you have s, it is like s plus a. So for removing this a, you have to put e power minus at in the front. So e power minus at into L inverse of s by s square minus 1. So this is nothing but when you get negative sign in the denominator, it is hyperbolic function. So this is cos ht. Okay, right. So I find the value for y. Similarly, you have to find the value for x. So for that, again you take the two equations. See, these are the two equations, no? In the two equations, you want to remove y, no? So for removing y, keep the first equation as it is. S plus a y bar minus x bar equal to 1. Second equation, you multiply by s plus a. So s plus a the whole square into x bar minus s plus a into y bar equal to 0. Okay, now you add the equations. Okay, because this y bar and this y bar are in opposite sign. So simply adding will give you x bar alone. So s plus a the whole square minus 1 into x bar equal to 1. So x bar equal to 1 by s plus a the whole square minus 1. Therefore, x is equal to L inverse of 1 by s plus a the whole square minus 1. This a can be removed by putting e power minus at in the front into L inverse of 1 by s square minus 1. This is nothing but sin ht. So, we obtain the values for x and y. X equal to e power minus at sin hat and y equal to e power minus at cos ht. Okay, this will give you the solution. Right, next problem. Now this problem contains ordinary differential equation with variable coefficients. In the previous problems we have discussed only with constant coefficients. Here you see d square y by dt square is having coefficient t. This is a variable, no? So again here see already I have posted so many videos in differential equations. In all the general types that I have discussed, this equation cannot be solved by the general methods that we generally use for solving any differential equation. Okay, so but this can be easily solved by using Laplace transform. Okay, right. So I'm going to solve this by using Laplace transform. So the procedure is the same. So you take Laplace transform on both sides of this equation. So this equation is nothing but t y double dash minus 2 plus t into y dash plus 3y plus equal to t minus 1. And y of 0, y dash of 0 are both 0. Now L of t into y double dash minus 2 into, I am taking Laplace transform. 2 into L of y dash minus L of t y dash plus 3 into L of y equal to L of t minus 1. Now here you apply the formula. Sorry, before applying the formula, see here I am having L of t into y double dash, no? So when you have product, in the beginning of the video itself I gave you one formula, no? So when you have t here, look at the power of t. Power of t is 1. So it will be minus 1 into d by ds of L of y double dash. This t can be eliminated by differentiating the Laplace transform. Okay, so the value of this is minus 1 into d by ds of L of y double dash minus, here simply you write the formula for L of y dash, 2 into s into L of y minus y of 0, plus here also you are having t, no? So what to do? T power 1, so minus. So already you have one minus, so minus into minus will become plus d by ds of L of y dash plus 3 into L of y is what? Y bar equal to Laplace of t is 1 by s square minus Laplace of 1 is 1 by s. Okay, now you apply the formula for L of y double dash and L of y dash. So minus 1 into d by ds of, this is s square into y bar minus s into y of 0 minus y dash of 0 minus 2s into y bar. Okay, y of 0 is 0 given in the question, so no need to write it, plus d by ds of, for this one the formula is sy bar minus y of 0 plus 3y bar equal to, here you take LCM, it will be 1 minus s by s square. Now all these y of zeros, y dash of zeros will get eliminated because they are all zeros, no? So no need to write. So minus 1 into d by ds of s square y bar minus 2sy bar plus d by ds of sy bar plus 3y bar equal to 1 minus s by s square. Now we want to differentiate this function. This is product of two functions. So I have to apply UV rule. Okay, so s square into differentiation of dy bar by ds plus y bar into differentiation of s square is 2s minus 2sy bar. Similarly here also you have to apply product rule. S into dy bar by ds plus y bar into differentiation of s is 1 plus 3y bar equal to 1 minus s by s square. Now you collect the terms containing dy bar by ds and y bar. So dy bar by ds into Okay, here it is s, here it is minus s square. So s minus s square plus y bar into, here it is minus 2s and here minus 2s is there, and then here plus 1 plus 3 equal to 1 minus s by s square. So you take common factors, s into 1 minus s is common for all the terms. So s into 1 minus s if you take outside, sorry, 1 minus s is common which you take outside, you can cancel on both sides. So what I have simply s into dy bar by ds plus 4y bar equal to 1 by s square. Okay, throughout you divide by s. So what do you get? Dy bar by ds plus 4 by s into y bar equal to 1 by s cube, right? So this equation we have to, this is a linear differential equation, first order linear differential equation which you have to solve. Now see, this equation is of the form dy by dx plus py equal to q. Again, solution of first order differential equation video I have already posted. It is there in the playlist. If you want, you can go through that video also. So this is of the form dy by dx plus py equal to q, where this capital P and Q are purely functions of this variable x. Okay, here s is the independent variable. So if you have equation like this, its solution is given by y into e power integral p dx is equal to integral q e power integral p dx plus c. This y is the dependent variable and p is coefficient of y and q is the right side. So here it will be y bar into e power integral. What is in the place of p here? 4 by s into ds equal to integral 1 by s cube into, this same term is here. Okay, e power integral 4 by s ds plus c. So this is integration of this is 4 into log s equal to integral 1 by s cube in e power 4 log s ds plus c. Now 4 log s can be written as log s power 4. E power log s what? Simply s power 4. So y bar into s power 4 equal to integral s power 4 by s cube into ds plus c. So it is simply what? Integral s ds. Now bring this s power 4 to this side. So 1 by s power 4 into integral s ds plus c. What is integral s ds? S square by 2 plus c. Now bring this 1 by s power 4 inside. So what do you have? Y bar is equal to 1 by 2 s square plus c into 1 by s power 4. Now y is obtained by taking inverse Laplace on both sides. So y equal to inverse Laplace of 1 by s square plus c into inverse Laplace of 1 by s power 4. This is nothing but t, and here this is nothing but t cube by 3 factorial. Okay, 3 factorial is what? 6. So this is the solution.